Today I'm out at the National Weather Service in Boise trying to learn about how the weather people here work with so many other agencies nearby, like the airport, to let them know how they have to de-ice their airplanes in the winters, and the National Interagency Fire Center. Of course, with all the fires and smoke we have around Idaho, this is a great agency for them to work together with. So this is going to be what it's like backstage at the National Weather Service here in Boise.
Hi, my name is Megan Timish, and I'm with the National Weather Service in Boise. I'm a meteorologist here, and we're going to talk a little bit about what we do here at the office. The PCs, because we do a lot of, we do like Facebooking, Twitter. I can show you all that later too. And then a lot of the information we retrieve, just observations, webcams, stuff like that, is via the internet. So we use that quite a bit. But then we have these other systems. We call them like the graphical workstations. They're called AWIPs. Basically, it's how we view the weather via satellite, radar, model data, and then there's also software, and that's the one in the middle that is what allows us to manipulate the forecast and create it. So that's a temperature. That's Friday afternoon temperature forecast. Now these, like that outline, I don't know if you can tell, but you can see Idaho and you can see Oregon. But the outline is what we call it's our forecast area. It's our area of responsibility. And so up across the border, that's Pendleton's forecast responsibility. And I can show you all the offices too. Missoula has an office, Pocatello. So we focus in here, and the breakup is the zones, we call them. It's kind of an old school format, and it's broken out by climatological. Like obviously you're not going to lump the mountains in with the valley because there's going to be too much variance.
So what's the Friday forecast say?
So the Friday forecast says right now we have a high of 38, which is very warm compared to what last week, right?
Right.
Looks like light winds. And the pop, see where it says pop? That's the probability of precipitation.
Okay.
So there's a 20% chance, 19% in the morning, and decreasing in the afternoon. Actually just derived from the snow level grid and temperature.
Oh, wow.
So some grid, we call them grids, each like variable is a grid. Some are dependent on other ones, like the weather type is going to be dependent on the temperature change throughout the day, because it actually gives an hour by hour like change. The QPF, that's just how much liquid is actually going to fall, whether it's rain or snow. And then snow amount is derived from that liquid and temperatures and snow levels. To us.
So how much of what you do here affects the national feed, or how much of what they send affects what we hear?
It depends, because what we kick out will often, like if you watch the Weather Channel, like it'll get scrolled on the bottom. But some of those national, like non-public forecasts, get theirs from private companies like AccuWeather, or have you ever heard of? Yeah, I'm sure you see that. But the national, like gridded forecast from the Weather Service is our actual work, and every office's work. It's kind of interesting.
Specific things you probably subscribe to that aren't, available for most people, but what would you say is like a favorite website or two for regular people to
view our?
Yeah.
All of this information can be found in some form or another. You can actually see the physical grids on our website. So if they wanted to see actually, like each variable and what we're doing, they can do that. It's just people prefer to click on their lat long and get that text. When he does the weather balloon, we release that into there, and it sends us information about the temperature and the dew point.
Okay.
So we have moisture and temperature, and we have winds at all the way up through the atmosphere until the balloon bursts. And that's a critical part of the forecast, because not only do we know, because really an inversion, it's just normally when you go up in the atmosphere, the air cools. An inversion is opposite. I don't know if you know that. The temperatures are inverted. So the profile, instead of it getting colder as you go up, I'm doing this because that's how we think of it in our head. Instead of getting colder with height, it's actually warmer. Like Bogus Basin will be warmer than Boise. So this is done early in the morning and then every afternoon.
Cool.
We track them via GPS now. That's what we do today, so it might be interesting. Those are the most fun to watch.
Fly away the balloon.
light snow around Pendleton, maybe a mix, and out toward Portland, and even here in Missoula. So we're still in that zone.
Yeah.
But the good jet dynamics have shifted off to the east. So what the models are showing in the short term is that after the winds drop out tonight, everything kind of shifts a little bit to the north and east. So through tomorrow, is that kind of what it showed?
Yeah.
Through tomorrow, it looks like we're still in that zone, but the really good dynamics are here versus right over us. But there's still enough support and upslope that I think around Baker County, the edges, the higher elevations, and then around McCall, at times even the Boise Mountains will get some light precipitation. So on the grids, we have snow amounts. So we've had reports of wind gusts 40 to 45 at Twin, and actually we had gusts 40 to 50 down Jackpot. 11 p.m. So look pretty interesting. It's gotten better, but the winds really up around McCall. Yeah, and if I run a total, it's like 3-4 inches. It wasn't enough for advice, right?
It's got like zoomed in here. So if you go to our website and you want a forecast for Boise, that's what comes up. Now all of that text, that's not anyone typing that in. That's the computer program taking all those images, squishing them together. And there's a lot of manipulation and a lot of work that went into making sure it takes whatever's in there and makes it make sense of what the forecaster really wanted it to say.
Right.
But see this box? So every time you move that box, it's a 2.5 by 2.5 kilometer grid box. And so there's a specific forecast
I've never played
made
with
from
that.
those images.
Okay.
Yeah. So like if you're gonna go, the nice thing about this, especially out west, is it used to be you just get forecasts for cities like Boise, Twin Falls, but this you can get a forecast for local spaces,
Specific neighborhoods or
like the outdoors, the backcountry.
A cool thing that Megan gave me is this chance for you to measure your own precipitation and check out the weather in your community. Whether you're in Boise or a small town, you can enter this information. It's very helpful to the National Weather Service. It's good for retired people and kids, anybody who wants to have some fun with the weather. This is the website you'll want to go to. You will need to get just one of these that measures precipitation. Other than that, you'll get in the system and be able to make your own help with the weather reports. This is the website to go to for that.
It's kind of interesting because if we get really locked in with the inversion and the temperatures are right, the airport can use cloud seeding to lift the fog essentially. And it will, here at the office, it will snow temporarily. So it'll be snowing like here in the airport and nowhere else. It's pretty funny. So at 500 millibars, your strongest winds are usually going to be, look at over here. There's a little pennant with a line, so that means it's 60 knots. We have 70 knots, way up here 80 plus knots, I think. It's hard to see, but that's associated with that weather system that's compensating all that severe weather.
Right.
And that's one component that aids in, I guess, the production, the development of severe weather, is wind shear, which basically, as you go up in height, does it change in direction? Does it change in speed? And that aids in thunderstorm development, allows for circulation to develop, something like that. So there's a lot of weather going on there, like across the, Louisiana. And different types of weather, I'm going to want to look at different things. And for different seasons, I'm going to want to look at different things. One of the first things I always look at is the big picture. And I'll use a water vapor. Wow. This is water vapor satellite image. So, and what you can see is I have an overlay. Those lines, we call them contours. That's actual model data. That's overlaid onto the satellite image. The coast, And so you can see it even without the height contours.
Mm-hmm.
And you can see it put in motion. Now, what's causing this morning's weather? What caused that is there's moisture coming up from the Pacific, riding around this high pressure ridge, we call it, and the flow's moving from the northwest into Idaho and Oregon. And so with the cold weather or the cold air already in place and the moisture moving in, what normally would have been rain, but we've been so cold lately, came in as snow. And so we had about 3 to 4 inches of snow depending on where you were at. Something also interesting, these pink lines are the Storm Prediction Center in Oklahoma City puts out convective outlooks. So if you've ever heard of them, they're a national center. They're the National Weather Service, but it's a center that does services for the whole United States. And they pinpoint areas that they think severe weather is going to develop. And then the forecast areas, like the Boise forecast area, will hone in on that. And they pretty much already know what's going to happen, but it's kind of like everyone agreeing on what's going to happen. And then the local areas will issue the actual tornado warnings or the tornado watches. The watches are kind of a collaboration between the local forecast office and the Storm Prediction Center in Oklahoma City. And then the actual warnings are issued by each office.